Hello and welcome to this episode of Math with Martinez. We are in our 7th unit in Algebra 2, where we are looking at cubic and cube root functions and equations. And today we're focusing on writing inverse functions. Whenever you're writing the inverse of a function, if that function is f of x, its inverse would be written as f, matching, right? It matches the function name, but we would denote it with this little -1 as it looks kind of like it's in the exponent or superscript position. That is how we denote the inverse of a given function f. In order to find the inverse of a given function, we'll be following these steps. Step number 1 is to replace f of x with y. Step 2 is to switch x and y. Step number 3, to solve for y. And then lastly, to rewrite it using that function notation. This is not the first time we've found inverses, but now we're looking at finding inverses for this function family. So let's find the inverse of the cubic functions here together. Step number 1, we are going to be writing, instead of f of x, we're going to replace that with a y. So that looks like a y right here. And then the rest of our equation stays exactly the same. That is step number 1. Now step number 2 is going to be to switch the x and y. So everything else stays the same. The 3 stays here. It's going to be cubed and add 2, but ladies and gentlemen, we need to switch the position of x and y. So instead of y, we write x, and instead of x, we write that the y is now cubed. Now let's begin solving for our y. Whenever you're solving, you want to use PEMDAS. Use that in reverse order. So you want to start by undoing any adding or subtracting. So in our case, we'll undo the adding of 2 by subtracting 2 on each side. That's going to give us x minus 2 equals 3y cubed. Then we want to undo any multiplication or division, which we do have. We have 3 multiplying with our y cubed. So we're going to divide each side by 3. And that gives us x minus 2 over 3 equals y cubed. The last step is going to be to undo the cube, and the inverse operation of cubing is to take each side and cube root it. That operation is the opposite operation of cubing, so it will cancel that out, and we will be left with the cube root of x minus 2 all over 3 equals y. Our final step is to go ahead and in place of y, rewrite this using that inverse function notation. So that's to say f inverse of x is equal to the cube root of x minus 2 all over 3. That is the inverse function of our given function f of x. We started with a cubic function, and its inverse was a cube root. So there we have it. That's one example. Let's do another one. Let's follow these steps to find the inverse of this function, f of x. All right, so to begin, replace f of x with y. Everything else stays the same. Switch x and y. So this is now an x, and this is a y. And then we start the process of solving for y. So I'm going to want to add 1 on each side. I'm doing first adding and subtracting. Now, notice that my addition of 4 is inside of the parentheses. So I actually cannot undo that operation inside of the parentheses until I've actually undone the fact that this quantity, the y plus 4, is being cubed. So what I actually need to undo next is the cubing. I'll do that by doing the inverse operation, which is to take the cube root on each side. That's going to give me the cube root of x plus 1 equals, now that cube rooting of the quantity cubed will leave me with just y plus 4. Now I can undo that adding of 4 by subtracting it on each side. It's really important here that subtracting 4 comes after we took the cube root of the x plus 1. So it needs to come outside of that cube root. And there we go. We have solved for y. Y is now all by itself. So we're ready to go ahead and write our final statement. And that's to say that f inverse of x is the cube root of x plus 1, and after that, minus 4. These two examples, we're finding inverses of cubic functions. Now we're going to look at finding inverses of cube root functions. So let's go ahead and begin. Same steps apply here whenever you're finding the inverse. We begin by replacing f of x with y. Then we're going to switch x and y. Now we begin the solving procedures, solving for y. Let's get y by itself. I'm doing first, remember, doing PEMDAS in reverse order. So undoing any adding or subtracting. That means I'm going to subtract 3 on each side, giving me x minus 3 equals the cube root of y minus 5. Then I cannot, like we saw in this last problem, if what you're trying to undo, if you're trying to get y by itself, but there's this operation inside of a group or inside, like we see here, I like to sometimes call this not PEMDAS, but I like to call it GEMDAS, because inside of any group, that would be the last thing you can work with. So we're going to have to undo the grouping that occurs because I'm taking the cube root of the y. I'm taking and creating a group right here of the y minus 5 by taking the cube root of it. So we'll need to do the opposite operation, and that is to take this and cube it. Take both sides and cube. That will undo the cube root, leaving us with just y minus 5 on the right. And now we have x minus 3 cubed. All right, one more step. To undo subtracting 5, we will add 5 on each side, giving us the quantity x minus 3 cubed. And then plus the 5 is what y equals. So we'll write our final statement as f inverse. So we know that this is a function That is the inverse of a original function called f. And it is the quantity x minus 3 cubed plus 5. All right, you guys, just about done. Let's do one more example. Following our steps once again, in order to find the inverse of this cube root function. Here we go. Let's do it. Start by replacing f of x with y. Then switch your x and y. Then begin solving for y, undoing any adding or subtracting as long as they're not inside of a group. So I have minus 1, which means we're going to need to add 1 on each side. Okay, now I am multiplying by 1/2. And so instead of dividing by 1/2, we don't usually divide by a fraction. Let's make a little note here. Instead of dividing by a fraction, we will multiply by the reciprocal. And the reciprocal is when you are able to switch the numerator and denominator of your fraction. So what that looks like is on both sides here, on both sides, give yourself a little room in front of this group. I'm going to multiply by the reciprocal of 1/2, which is 2 over 1, which is the same thing as just writing 2. But I'll leave that 2 over 1 just so we can see that was the reciprocal. So that's going to cancel this operation here. And we're ready. We've got 2 times the x plus 1 equals, now all that's left on this side is the cube root of x. And last but not least, to undo the cube root, we're going to need to cube each side. Oh, let me do this on the next line. We're going to need to take this quantity and cube it, and we're going to need to take the cube root and cube it. So that will undo that operation. And on the other side, let's see what we have. We need to take and cube the 2, which would be 8, and then we need to cube this group as well. And, oh my goodness, I've been writing this as x. I never changed it. All these x's should be a y. I'm sure you saw that ages ago and were trying to tell me, right? You were screaming through the video. Now we've got our y by itself. Thank goodness. Okay, so now instead of y, we'll write f inverse of x. There we go. That would be the inverse. And you might be wondering right here why I didn't just cube the 2 and get 8, and then write this as x cubed and 1 cubed. Well, remember that really when we're cubing something, that means to multiply it by itself 3 times. So yes, 2 times 2 times 2 is 8. But if you take x plus 1 times x plus 1 times x plus 1, that is not equal to, that's not equal to x cubed plus 1. No, no, no. It is going to be a much larger thing if we expand it out. So we will just write it in this condensed fashion like we did, x plus 1 cubed. So there we have it, ladies and gentlemen. That's it for this video on inverse functions, inverses of the cubic and cube root functions. If you had any questions about this content, would you please take a moment and share those now? And until next time, stay fired up.